Good evening. Right, this is VK3 Echo Kilo Hotel, VK3 EKH, the official station of the Astronomical Society of Victoria, with the regular Friday night broadcast coming to you from the studios of VK3 CSJ in Narre Warren South. We're broadcasting on prime frequency of 3541 kilohertz in the 80 meter amateur radio band, and simulcasting on 160 meters on 1865 kilohertz in the 160 meter amateur radio band. This is VK3 EKH ASV radio, broadcasting from the studios of VK3 CSJ in Narre Warren South. We're also streaming via YouTube. You can find the YouTube stream via the ASV website page at www.asv.org.au. Look for the reference to the ASV radio broadcast under the Radio Astronomy tab. But simple as still, you can go to my YouTube channel and just type in VK3CSJ in the YouTube search engine, and look for the little live symbol that comes up against the channel, and that'll be the HD tube channel, the tube channel. All right, we're also broadcasting through the Melbourne television repeater, VK3RTV, digital channel number 1, and we say a very pleasant good evening to all the viewers on VK3RTV, which I shall just check to see if it's going out over the over BATC. I'll just refresh the BATC, the British Amateur Television Club video server. From what I can see, oh no, there I am. I am actually there, so there it is. I don't know if the sound is there though. Somebody might like to confirm if the sound is on the BATC feed, but I can see Visions is there, so that's good. All right. Great, thank you, producer. Oh boy, once again, it's a mad rush to get everything ready for tonight. I had all day to do it, but I leave it for the last hour to get everything sorted out. And I was planning on putting a podcast across tonight, courtesy of Brendan from Astrophiz Podcasts. He's got a wonderful interview with Dr. Susie Shi. I think that's how you would pronounce her surname. She's just released a book, but I'll give it a plug next week. But she's there's just a little thing that has spurred me on about it. So I'll mention it next week. But what I might do with that interview, so it's just a wet the lips thing. It's like the interview goes for almost 60 minutes, so I'm going to split it over 2 Fridays, so a half hour maybe next week, and the last half hour of the interview the following week, and I'll give her a reasonable airtime, but nevertheless, yeah, just something of interest. So she's just released a book, and I'll give that a bit of a plug as well. Yeah, all right, so we'll go on with that next week. Otherwise, meanwhile, we've got a few little articles tonight, and we have a solar report from our Space with a Woman, Tamitha Scove. We haven't had a report from her for a while, so this is a few days ago that it was released, but it's relatively current. And for those that are chasing shortwave and DX and whatever on HF, this will be of interest to those with a HF interest. Yeah. Okay. Welcome to everybody that's listening tonight. We also have an email address. If you wish to send reports, signal reports tonight, please send it email to vk3ekh@gmail.com. VK3 Echo Kilo Hotel, vk3ekh@gmail.com. And that's our email. I'm looking at the inbox as we speak. We also have a chat window. Thanks, Mike. We have a chat window courtesy of Discord. which you can log into more or less via a link provided on the ASV website. Again, www.asv.org.au. And go across where it has the Radio Astronomy tab and click on that, and then follow the link to the ASV radio broadcast. And the link to the Discord channel. There must be an easy way of doing this, Richard, to make the Discord channel a little bit more obvious for everybody, so I don't have to go through all this URL business. Think about that. But for me, for announcing it, our Discord channel can be found via the ASV website under the Radio Astronomy tab. It's a little icon of a radio telescope, and that's about the best I can tell you. We already have a few on the Discord channel as we speak. At the top of the list, it looks like we've got Brendan listening in as well, Brendan O'Brien, courtesy of Astrophiz. G'day Brendan, if you tuned in and listening to, probably watching me on the YouTube channel, the HD channel. And g'day to Bruce, it's there too. We have Brett, VK2, sorry, I always do that, VK2CBD. G'day Brett. Martin, VK7JAH down in Tassie, Launceston. We also have Richard, VK3VRS, Cassiopeia, g'day Nebs. And Uncle Mike, who's just up the road. And we have currently 3 viewers on the BATC feed, so I don't know who they might be, but welcome to the ASV radio broadcast thing for tonight. Oh, what a mad rush, though. I was stressing out in trying to get things working here, because I still have issues with the audio here, trying to get feeds off the internet to go working out over HF and all that. And it's I don't know, I did have it working at one stage, but in mucking around here I kind of upset the apple cart a little bit. Anyway, alright, let's get the voice warmed up. By running through very quickly about the Astronomical Society of Victoria for those who don't know. The Astronomical Society of Victoria was founded in 1922. We have about, I think the last count I saw was just under 1,600 members scattered about the state and Australia and overseas. Membership of the Society is open to all persons with an interest in astronomy. The Society's objectives are to encourage the study and practice of astronomy, and to disseminate the knowledge of the science, and to provide greater facilities for this study among its members. Monthly meetings are usually held on the second Wednesday of each month, except in January, where the latter being held on a Saturday night. Meetings start at 8 p.m. at the Mullior Hall, National Herbarium, in Burwood Avenue, Melbourne, near the Melbourne Observatory, which is located adjacent to Shrine of Remembrance. Parking is available in Burwood Avenue, Dallas Brooks Drive and surrounding streets. Admission is free and visitors are most welcome. Privileges of membership include the right to borrow books, periodicals and other publications from the Society's extensive library located at Melbourne Observatory, receipt of the ASV magazine Crux containing articles, news, observing notes and the like, and the free provision of the Astronomical Yearbook published by the Society. Access is available to telescopes on members' nights held regularly at the Melbourne Observatory and after the monthly meetings, weather permitting. These instruments include the Society's 300mm equatorial reflector and a 300mm portable reflector. There's also a 200mm refractor which is managed by the Royal Botanic Gardens, and a photoheliograph are also housed at the observatory and are accessible too. The Society also has a number of 200mm reflectors available for short period loan to members trying before they buy. Regular Society Club Night meetings are held on the first and last Fridays of each month at the Lodge, the Society's property in Burwood. Members are encouraged to use the Society's instruments located there in order to gain first-hand experience in telescope use. These instruments include a 508mm equatorial reflector and a number of smaller reflectors. Members are also encouraged to make use of the Society's country property located near Heathcote, some 90-minute drive north of Melbourne. There are a range of instruments available for members to use. The larger two only with appropriate training, which range from 300mm to 1000mm in aperture. Also located on the site is an 8.5 metre radio steerable telescope, which members can access with involvement with the Radio Astronomy section. Members are encouraged to make and use telescopes. Advice and help on both matters are provided willingly to newcomers desiring to do the same. Instrument making is only one of the number of common interest activities catered for within the Society. Other areas of interest that members can participate in, including deep sky observing, astrophotography, lunar and planetary observing, auroral, meteor, comet, radio astronomy, computing, cosmology and astrophysics, historical studies, and research and astronomy in general. Contact details for various section directors are provided in the yearbook. Further information may be obtained by visiting the ASV website, and notifications of events are given in Crux Extra Bulletins, which is an email bulletin produced every other week to provide information to members between the Crux magazine being released. Please note that ASV will conform to all government health directives. ASV events may be required to be cancelled, moved and otherwise postponed. Information about the ASV can be gleaned by writing to the Secretary, the Astronomical Society of Victoria, GPO Box 1059, Melbourne, Victoria 3001. That's the Secretary, Astronomical Society of Victoria, GPO Box 1059, Melbourne, Victoria 3001. Or otherwise, you can go to the website at www.asv.org.au and all will be revealed. Thank you, producer. All right. Do you like for those watching TV, do you like my little cup here? Little cup dedicated to my little pussycat, Jessica, who passed away in August. My niece, Brianna, produced that little cup for me with the little pussycat pictures of Jessica when she was a little baby as she grew up. So I thought that was really, really good. I like that. Just thought I'd throw that in for those watching TV. It was a very visual thing, that one. Okay. Yes. Now, all right. Now, we have a little bit of sad news. It is sad news, actually. We like to acknowledge the passing of David Mckinley, VK3DRM, who lives up there at Cobram. I've had the chance to meet David maybe once or twice in the distant past. He used to live in Melbourne, but has been living up in Cobram for a while. But I've just received notice of the passing of David Mckinley, VK3DRM, who I understand was building an observatory, a telescope. He was interested in astronomy and was building an observatory with a pretty decent telescope, and was very, very keen in wanting to experiment with astrophotography. When I heard about that, I thought, this will be really good, because I'm in the same boat. I'm trying to get an observatory built up to house a telescope. And of course, my keenness in that area is astrophotography, and I was imagining that I'd be able to share information and photographs and images and whatever between ourselves, and I was really looking forward to that relationship in the astronomy side of things. But unfortunately, the news came through just a few hours ago. So Vale David, and yes, we sadly missed VK3DRM. So I'm dedicating tonight's broadcast to David's memory there. Okay. Right, just checking that. Back to VMix and the next story. Oh, Sky Notes. Okay. So got to keep an eye on the time here. To finish off some of the dates, courtesy of the planetarium, Sky Notes. I'll just read out a few dates. I'm not sure where I finished off last week. I think I went as far as I'll start off with the 20th of May. Okay, on the 20th of May 1990, the Hubble Space Telescope sent its first photograph from space, an image of a double star 1,260 light years away. So that was the 20th of May 1990. That was the first photograph from space from the Hubble Space Telescope. On the 21st of May, in Japan launched a spacecraft called Icaros. 2010, May 21, 2010 launch of Icaros spacecraft, the first successful solar sail technique used for planetary travel. Oh, that's interesting. I didn't know that one. On the 25th of May, in the year 240 BCE, first recorded close pass by of the sun of Comet Halley. Okay, so on the 25th of May, 240 BCE, first recorded close pass by the sun of Comet Halley. That's interesting. Okay. On the 28th of May, 1959, monkeys Abel and Baker are sent on a suborbital flight of 580 kilometers into space in the nose cone of the Jupiter rocket. Monkeys Abel and Baker. That was 1959. Also on the 28th of May, 585 BCE, going back a fair while this one, solar eclipse occurs during a battle between Medes, M-E-D-E-S, Medes and Lydans. Knowledge of past eclipses are enabled dating of other historical events. So, May 28, 585 BCE, solar eclipse occurs during a battle between Medes and the Lydians. Knowledge of past eclipses has enabled dating of other historical events. Also on the 28th, there's a few things happening here on the 28th of May. In the year 2002, water ice on Red Planet is discovered by the Mars Odyssey, and we have an article on that coming up in a minute. So 28th of May 2002, water ice on the Red Planet is discovered by the Mars Odyssey. On the 29th of May 1919, Einstein's general theory of relativity is confirmed by Arthur Eddington's study of distant starlight bending during a total solar eclipse. Also on the 29th of May 1794 is the birth of the first astronomer to map the Moon and Mars, Johann von Maduda. That one. And on the 30th of May 1975, European Space Agency ESA is created by merging Launch Development and Space Research Organisations. 1975, ESA was formed. Also on the 30th of May 1966, the launch of Surveyor 1, which will make the first landing on another body, in this case the Moon, 1966. That's all the dates. Thank you, Planetarium, Science Works, Tanya Hill, if it was Tanya Hill. Much appreciated. Very pleasant good evening to Bill, VK3KHT, who's no doubt watching the TV, and David, VK3KDM, of the MBO, Mount Burnett Observatory. G'day, David. Okay, you're tuned to ASV Radio, VK3EKH. 1020. Okay, I guess everybody has heard the news that's absolutely swamping all astronomical outlets today. The history of Sagittarius A, the Milky Way's supermassive black hole. Lifting the dust veil of the Milky Way's core has taken nearly a century. And I've got an image here, so there's actually a few images here, so I'm just going to switch across to the first image here of all this story. Where is it? Oh, that's it. There, okay. All right. I think our audio is still there. Hello. Yep, I think it is. Sorry about that. All right. Back to the article. What you're looking at there, for those watching the YouTube stream and the ATV, that image there is the supermassive black hole Sagittarius A at the center of our galaxy. One is in the radio wavelength and the other one is in X-ray and infrared. Before everyone knew about the giant black hole lurking in the center of our Milky Way galaxy was just an exceptionally bright source of radio emission. Because just as a sideline, just putting a full stop on that for a minute, the one of the basic things, I'll just come back to me for a second. One of the basic things about radio astronomy, and when I'm ever told or doing a presentation on doing radio astronomy and how do you get into radio astronomy, what's the basically first things you might want to do as a amateur radio astronomer, and I always go straight away to the NASA sponsored project called Radio Jove. And with the Radio Jove receiver, it's a very, very simple basic receiver. You can either buy it as a complete kit already, or you can build it up, but they are making it as a kit. But it's a direct conversion receiver, and it has no AGC. So it's only designed to operate around 20.1 megahertz, plus or minus maybe 150 kilohertz. And the idea of that receiver is that it's like a total power receiver. It's designed to detect variations in noise, radio noise. And that noise can be three major things that the receiver is designed to detect. Its prime purpose is to detect the decametric emissions from Jupiter, and what's normally known as the storms, Jupiter storms. There's short bursts, there are long bursts, sometimes a combination of. And so it's the Radio Jove as in Jupiter, project. But the other two things that this receiver can detect easily well is not only solar flare activity, coronal mass ejections from the sun, and now's the time to be detecting solar flares, but also the center of our galaxy. The center of our galaxy is about 26,000 light years away. It's a very bright source of RF energy, radio source. It peaks in the spectrum of noise, that radio noise that can be easily detected by a simple receiver and a simple antenna. In fact, this is the sort of thing that kicked off radio astronomy in the very beginning with Karl Jansky. So after all these years of discovering the center of our galaxy, Sagittarius A, in those early days when Karl Jansky put up his antenna and discovered the center of the galaxy, although he wasn't too sure what was going on, it's taken all this time to be able to photograph and get that much closer to the black hole that's in the center of our galaxy. And here it is today. We now have these images coming through. So I'll just go back to the article. Sorry, I didn't mean to go off on a tangent there, but I did. All right, back to the article. I'll just repeat that before I got distracted. Before everyone knew about the giant black hole lurking in the center of our Milky Way was just an exceptional bright source of radio emission. But since the discovery of Sagittarius A, pronounced Sagittarius A star, The black hole has continued to surprise and delight us, while all serving as a testbed for our most fundamental understandings of gravity. Calling on astronomers. Astronomers have known the rough location of the centre of our Milky Way for nearly a century. They first learned this by monitoring the position and velocities of globular clusters, finding that the clusters tended to orbit a common point. But try as they might to figure out if there's anything interesting in our galactic core, their telescopes couldn't spot much in that region of the sky. The problem was dust, lots of dust. And I can just bring up an image of that dust too. Oops, no, not that one. Hang on a sec, I'll just bring up the dust. There's the dust. So, lots of dust. All those dark, for those watching the TV and ATV, all those dark regions, those sort of browny patches, is what they're referring to as lanes of dust that we can't see through. Optically, we cannot see through. So the central core regions of the galaxy are so thick with dust that almost all forms of light go extinct before reaching Earth. But 26,000 light years away, full stop, to astronomers a century ago, the galactic centre was a mystery. And that image you're seeing on the screen is real. It's an infrared view of the centre of the Milky Way, courtesy of Caltech. But not all forms of light disappear behind vast veil of interstellar gas and dust between us and the galactic centre. Radio waves are known for their ability to sail through thick clouds of dust with relative ease. In 1933, the pioneering radio astronomer Carl Jansky, so pioneering that he has a unit named in his honour, the Jansky, used the newly minted idea of radio telescope to identify a surprisingly bright source of radio emission coming from the direction of Sagittarius, the constellation, as we mentioned before. Right away, astronomers connected this bright radio source with the galactic centre, and, in typical fashion for astronomy, they called the radio source Sagittarius A, because it was the first such source found in that constellation. Into the Dragon's Lair. The centre of the Milky Way is really far away, and radio telescopes typically don't have the greatest resolution. It wasn't until the 1970s that the invention of radio interferometry that astronomers gained a better picture of Sagittarius A. Radio interferometry relies on using multiple detectors to try to capture the same image. Astronomers must carefully coordinate the separate data streams from all radio telescopes to build a cohesive picture, a process that requires intensive computations. Interferometers do have their weaknesses. For example, the bare ground between the telescopes does not capture any usable data, so there is a lot of loss of information. But they also have one major strength. In astronomy, the bigger the picture, the higher the resolution you can achieve. For interferometer, the farther apart you set your individual telescopes, the smaller the object you can resolve. I've got one picture here, another picture to bring up of this. Bring that there. Okay. In this picture that you see on the screen here, which is actually this print there already, but it's basically the Event Horizon Telescope utilizes a technique called very long baseline interferometry to link radio telescope arrays across the globe and create a virtual telescope the size of the Earth. To peer into the centers of the Milky Way and M87, astronomers in 2017 used 8 radio telescopes at 6 separate locations. Since then, the EHT has added sites in Greenland, France and Arizona, which will improve the array's observing capabilities for the future observing campaigns. And you can see the image there of where these radio telescopes are on the globe, and once they're all interconnected, it makes one very large radio telescope. To continue on, with these interferometers, radio astronomers were able to identify an exceptionally bright small spot buried in the heart of Sagittarius A. The astronomers were so surprised by this spot that they named it Sagittarius A, applying the asterisk usually used to denote an excited state of an atom. Equipped with clearer and more detailed observations, astronomers were able to start placing estimates on the size and the mass of the object emitting the radio waves. They found that it was both smaller than our solar system and millions of times more massive than the Sun. There's only one kind of object in the universe that fits that description: a supermassive black hole. The supermassive black hole at the centre of the Milky Way doesn't emit light itself. It is a black hole after all. But all the gas and dust surrounding the monster is perfectly capable of emitting light. As it violently swirls, compresses on its way to the event horizon, the material can reach scorching hot temperatures approaching 18 million degrees Fahrenheit or 10 million degrees Celsius. At those temperatures, the material quickly forms a thin, rapidly spinning accretion disk, which emits intense amounts of radiation across the entire electromagnetic spectrum. And there's another image here I'll bring up. Let me see, where is it? There it is. I'm about to talk about this one. Okay, so what you're seeing there, in this case, it is an artist's impression of stars orbiting very close to Sagittarius A. Here represented as a small blue circle. Now hopefully you can see that on the SD transmission up there on the repeater. But in the center there's a small blue dot, which is basically where the black hole is located. But what we have are stars that are rotating around it. They've actually got movie. I don't think I've got that here, no. But there's actually a film that's being, and it's kind of like an animated film, but it's actually an image of the stars orbiting this black hole, but it's taken over a long period of time, and they've knitted the images together. And you can actually see, when it's sped up to at a faster rate, you can actually see these stars clearly orbiting a central point, which is the black hole. So in continuing on, further advances have allowed astronomers to achieve incredibly high precision observations, tracking individual stars as they orbit Sagittarius A at up to a few percent the speed of light. Those observations are crucial as the stars weave and dart in and out around the supermassive black hole in their orbits. By carefully watching them over years and even decades, astronomers can deduce the properties of gravity in this extreme environment. Providing an instrumental test to Einstein's general theory of relativity, these speedy stars also serve to clearly demonstrate that Sagittarius A is indeed a black hole, as other arrangements like a dense clump of dead stars would result in different orbits. Now the next image is the first image created or not created but recorded of a black hole. This is not the one at the center of our galaxy, but rather, have I got it? I think this is it. M87. I think this is M87. Alright, back to the article. Yeah, it looks like it. This is the first, what you're seeing on the screen now is the first image of a black hole. Hole shows the supermassive black hole in the heart of galaxy M87. Since the 1970s, interferometry has evolved into VLBI, very long baseline interferometry, which stands for, I've just read the article, Clint. Essentially, VLBI is a souped up interferometer with the distances between individual telescopes stretching across entire Earth. This has given astronomers unprecedented views of the center of our galaxy. Now, a shining example for VLBI is the event horizon, which in April 2019 released this first image 19 of M87. Okay, now that's interesting. All right. Okay, so we go back to this first image. I'll go back to this first image because the one that you want to see is this new picture of the black hole, which is this one. Okay, so that one there, what you're seeing up there, it's not a full size picture, but that is the radiation, RF radio emission being emitted by the black hole at the center of the galaxy. So you've got an image in radio and an image in X-ray and infrared that you can see on the screen. So that's what they're all carrying on about in the last couple of days is this final image of the black hole. Very good, isn't it? I think so. If Carl Jansky could see that right now, I think he'd be blown away. You're tuned to ASV Radio, VK3 Echo Kilo Hotel, broadcasting on 160 metres, 1865 amplitude modulation, and prime frequency 3541 kilohertz on 3541. And via the Melbourne TV repeater, VK3 RTV, and via YouTube, and that's about it. Yes, we have a report from Don, VK. What's that? What's it say? Say again? And Discord. Okay, and of course Discord coming from the background producer there. Thanks, Richard. That's VK3 VRS on the Super Channel. Okay. Next, thinking what's next here. Alright, there's no images with this article, but it shall only take a few minutes to read out. Okay, sorry, I'm flustered. Spot the difference to help reveal Rosetta image secrets. When was that released? Give me a date. The 5th of May 2022, so this is current. I've been actually holding on to this article. Today, on the 5th of May, at least, today ESA and the Zooniverse launch Rosetta Zoo. It's a citizen science project that invites volunteers to engage in a cosmic game of Spot the Difference. By browsing through pictures collected by ESA Rosetta mission, you can help scientists figure out how a comet's surface evolves as it swings around the Sun. Rosetta spent over 2 years orbiting Comet 67P between the years 2014 and 2016. The spacecraft studied the comet up close, collecting unprecedented data to unlock some of the most intriguing mysteries surrounding the formation and evolution of our solar system. Partway through Rosetta's studies, the comet approached the Sun. A moment known as perihelion. Following its closest approach of about 186 million kilometres from our Sun, the comet then moved away again, as they normally do. This meant that its surface was illuminated in different ways during the course of Rosetta's mission. Rosetta witnessed many landscape changes on Comet 67P, from the impressive fall of cliffs and the formation of pits to evolving dust patterns and rolling boulders. Scientists are interested in using these changes to investigate the detailed mechanism through which a comet sheds its outer layers as sunlight heats the ice and dust surrounding the nucleus. The sheer number of surface changes, however, makes charting them a highly complex task. So scientists are looking for your help. Vast amounts of data need a vast number of eyes. Rosetta Archive, which is openly accessible to scientists and the public, contains a vast amount of data collected by this extraordinary mission that have only been partially explored. In the past few years, astrophotographers and space enthusiasts have spontaneously identified changes and signs of activity in Rosetta's images. Except for a few cases, though, it has not been possible to link any of these events to surface changes, mostly due to the lack of human eyes sifting through the whole dataset. We definitely need more eyes. This is why ESA partnered with Zooniverse, the world's largest and most popular platform for people-powered research. The new Rosetta Zoo project presents a particular set of data, pairs of images collected by Rosetta's OSIRIS camera, showing Comet 67P surface before and after perihelion. Volunteers are invited to view the images of roughly the same regions side by side and identify a variety of changes, from a large-scale dust transport to comet chunks that moved or even vanished. Sometimes this may require zooming in or out a few times, or rotating images to spot changes on different scales, getting up close and personal with the iconic comet. Given the complexity of the imaging, the human eye is much better at detecting small changes between images than automated algorithms are, explains Sandor Kurik, a postdoctoral researcher at the Max Planck Institute of Extraterrestrial Physics near Munich, Germany, who discovered and initiated the project using his ESA Research Fellowship a couple of years ago. The OSIRIS images have been publicly available in the archives for some time, but many images have not been analysed yet for changes in surface of the comet. This is why we decided to set up this citizen science project and ask for volunteers to inspect Rosetta's images of 67P. Given the excitement Rosetta generated during its mission, we hope this project will be joined by many members of the public to help scientists analyse the data it has generated. Thanks to the visual inspection of many volunteers, the project will produce maps of changes and active areas on the comet's surface with labels for each type of change. Scientists will then be able to associate the activity of the comet with modifications on its surface, developing new models of link and the physics of comet activity to observe changes such as lifted boulders or collapsed cliffs. By digging through Rosetta's images and playing a cosmic game of spot the difference, you will help us reach new heights in our understanding of comets and the solar system as a whole. But the benefits go both ways. We hope that by opening up this data to the public, we are improving the openness of our work, increasing citizen engagement in scientific research, and building on stronger connections between science and the society. Anybody can use Rosetta Zoo online for free without needing to sign up, install an app or program, or have any previous scientific experience. Spot the difference between as many as a few images pairs as you have time for, whether the first 5 minutes whilst waiting for a bus or regular evenings of cometary exploration. What does a primitive comet look like? No one knows. But with the help of volunteers, we can characterize how comets evolve and understand the physics driving those changes. Then we will be able to rewind the movie of cometary evolution all the way back to the origin of the solar system. So there it is, Rosetta Zoo, and go using your eyes to spot the difference. Sounds like an interesting one. You're tuned to ASV Radio, VK3 Echo Kilo Hotel, coming to you from the studios of VK3 CSJ on on all these frequencies and whatnot. Now time is 1:45. Oh yeah, okay. Now this is an interesting one. One might have thought this was a conspiracy theory. I pity those that get sucked into conspiracy theories, but this is real, supposedly. Okay, I'm going to bring this image up straight away. Some of you may have seen it, some may not have, but you'll get the drift where I'm coming from. Okay. All right. On the YouTube screen and on the TV repeater, you have the article starts by saying, this is published 12th of May. Spooky discovery on Mars looks just like an alien doorway. One of the most recent snaps beamed back from the Curiosity rover on Mars has revealed a rather interesting feature in the rocks. What looks like to be a perfectly carved out doorway nestling in the Martian landscape. The doorway, a doppelganger, is so eerily convincing we're almost tempted to start believing that it leads to a little hideaway of Martians, or perhaps a portal to another universe entirely. We're also getting we are also getting tunnel to the center of the planet vibes from this. At the very least, the picture and the geological features it's captured would seem to be enough to inspire a science fiction movie or two. There is a coloured image of this. I'll just bring up the coloured image now too. Okay, there we are. Back to the article. However, I mean, it does, doesn't it? It looks like a doorway. It looks like finally we've discovered something on Mars that's got to be made by some intelligence. However, the far more sensible people of Reddit, R-E-D-D-I-T, I'm not sure what that exactly refers to, but anyway, however, the far more sensible have pointed out to this likely being a shear fracture, the result of some kind of strain on the rock breaking part of it off, perhaps given a helping hand by a Mars quake or two. In fact, the largest temblor, T-E-M-B-L-O-R, temblor recorded on the red planet so far happened on May 4 this year, and scientists are still working to pinpoint where exactly it happened and what caused it. What's more, while the door-like rock formation may appear to be full-sized in our imaginations, it's possible that the cavity seen is only a few centimetres or inches tall in real life, though it's difficult to be certain from the picture. You can see a bigger, colorized version of the original picture on the screens right now. The doorway shape is up towards the top of the composite image, a little to the left of the center. The image was taken at a geological feature known as the green hue pediment of the mast camera on board Curiosity on May 7, 2022. In the years that we've had access to the close-up images or close-up of Mars from landers and orbiters, we've been treated to some truly weird and wonderful snapshots of the red planet. Craters filled with ice, strange chevron-shaped rock formations, hollowed-out mountains, and plenty more. In terms of spooky discoveries in space that appeared to resemble alien structures, it's important that we don't get too carried away with what grainy images can sometimes suggest, and this is the thing. You may remember the strange cube-shaped object spotted on the moon by China's Yutu 2 rover last year. After further investigation, it turns out that the alien hunt was simply another rock, with tricks of light and perspective giving its cuboid shape. Similarly, we suggest that this mystery doorway will ultimately have an explanation that's just as ordinary, but we're having plenty of fun speculating in the meantime. So it's pretty good though, isn't it? So there it is. I just thought I'd throw that into the mix as well. All right, now how long does that go for? All right, I'm going to go straight to our space weather woman, because her solar report goes for 11 minutes, I can see. So we're going to finish off with Tamitha. Now let's hope I can get all my audio patching here works, and that we can get a feed across to HF and everywhere it needs to. So if you don't hear any audio straight off, I'm working desperately to get the audio patch through, but I think it's all going to work. This is VK3 Echo Kilo Hotel, VK3 EKH ASV Radio.
We have two Mfler players on the Earth-facing disk two filaments that are poised to erupt, and an Earth-directed stealthy solar storm. Those stories and more in the news this week.
Why isn't there any audio there?
This space weather forecast is sponsored in part by
We're working on the audio problem
University.
here for HF users.
Come get certified in broadcast
I did
space
have that
weather.
working before.
Visit millersville.edu/SWEN. Space weather this week is continuing to keep our attention. As we take a look at the Earth-facing disk, all eyes back around the turn of the month were on the east limb as old region 2994 began to rotate into view, and it started firing off big M-class flares and even an X-class flare before it was fully in view yet and got its new number. Its new number is now 3006, and while we've been watching this region firing off a bunch of flares, region 3004 also started to develop, and by the third, this region was firing off big M-class flares and an X-class flare. In fact, this region on the third destabilized a whole larger region that then launched a stealthy Earth-directed solar storm, and we're going to talk more about that in a minute. Meanwhile, these two regions have been continuing to trade M-class flares back and forth. They are still X-flare players, so we are keeping an eye on them, but we are also keeping an eye on the two filaments that are sitting here in the north. The first one here actually looks like it's kind of erupting a little bit as we speak, but the second one looks like it's getting unstable, and that would mean we could possibly get yet another Earth-directed solar storm, so we're definitely going to keep our eyes on those. Meanwhile, we have yet another region that's going to be rotating into Earth view here in the next couple days, and it is also a solar storm producer. So aurora photographers, man, you're going to get a lot of chances for potential aurora here over this next week, and amateur radio operators and emergency responders, those radio blackouts are going to keep on coming. Switching to our Mfler threat meter, you can see as we take a look at the X-ray flux back on the 30th, you can see things rising quite quickly and pop, pop, pop. Look at all these big flares. This was all due to region 2994, which became relabeled 3006. And you can see that big X flare there. That region continued to fire easily over that day before things began to calm down just a little bit. And it definitely caused some radio blackouts. Luckily, we got a little bit of a reprieve into the second, but then region 3004 started really growing rapidly, and you can see once again back by the third, pop, pop, pop. Once again, we're getting these big flares, including an X flare. This is from region 3004. This is also about the time when that stealthy solar storm was launched toward Earth that is still making its way towards Earth and should hit us around the 9th. Meanwhile, things continue to ramp back down a little bit, but regions 3004 and 3006 are both still big flare players, so don't expect these radio blackouts to go away anytime soon, and this means amateur radio operators and emergency responders, especially those using GPS reception, you're going to be dealing with radio blackouts on Earth's day side, and this does extend into dawn and dusk, so be aware of that. Plus, we have that new region that's going to be rotating into Earth view over the next few days, and that means big flares will remain on the menu. Switching to our solar storm conditions, as you can see, back on April 30th was really the last time we actually had any decent activity. Mainly this was due to some fast solar wind, but we had a little bit of solar storms, like mini solar storms packed in there, and that managed to bump us to active conditions and then up to storm levels for a short bit before things began to settle down. Now we did have another solar storm, but it grazed us on the 1st. It grazed us off to the west. That managed to keep us at unsettled conditions for a little bit, but really didn't bring us a lot new aurora chances. So things have been settling down, and now we're kind of sitting at quiet conditions. And now we do have that other stealthy solar storm that is due to hit us right around late on the 8th and into the 9th. So possibly these conditions could bump up just a little bit, but I'm not going to get too excited because this storm is expected to be pretty weak. Now returning to that Earth-directed solar storm, this is our solar storm prediction model, ENLIL. This is NASA's version of the model, and you're looking down at the sun from the North Pole with Earth being off to the right. And you can see that solar storm being launched, and it looks like it's a direct hit toward Earth. In fact, the impact should be late on the 8th, early into the 9th. But the issue is that if we take a look at the north-south cut, you can see that most of the solar storm actually looks like it's going to go north of Earth, which means it could be a glancing blow. Plus the fact that the storm is slow means that it's likely going to be a pretty weak storm overall, even if it does hit Earth. However, if you're an aurora photographer and you're at high latitudes, well, this is a big enough impact that it might be worth a look. So what else does our sun have in store for us this week? Well, this is Stereo A. It's our partially far-sighted monitor. You can see here's Earth, here's the sun, and here's Stereo A staring at the sun just a little bit from the side. And as we take a look at the sun from Stereo's view, you can see region 3006 firing off those big flares. But look just behind that region on the east limb. In fact, you can see that region there. Pow! Right on the 5th, it fires off a big solar storm. So this is a big solar storm player, and in fact, it could be a big flare player as well. So what this means is that as this region rotates into Earth view over the next couple days, not only could we continue to see those radio blackouts, but we could also get some decent aurora from a potential Earth-directed solar storm. So aurora photographers, you should be celebrating. We have more chances for aurora when this region rotates into view, and we also will see that solar flux stay boosted. Switching to our moon, we are now passing through the first quarter phase on our way to a full moon, and by the 10th, the moon will be about 65% illuminated. So you night sky watchers, if you want to catch those dim objects in the sky, you're going to need to check your local rise and set times. Switching to your solar storm conditions and aurora possibilities over the coming week, we are anticipating the weak hit from that stealthy solar storm that's on its way to Earth. Now at high latitudes, NOAA is expecting active conditions with up to about a 30% chance of a major storm. But don't expect it to last all that long, especially considering that this is more of a glancing blow than it really is a direct hit. Now at mid latitudes, we're only expecting unsettled conditions, but we do have up to about a 25% chance of active conditions and even a skosh of a chance of a minor storm, but likely, again, this is probably not going to be something that mid-latitude aurora photographers are going to be able to see, so you're probably going to just have to sit out and wait for the next one. Switching to our solar flare and particle radiation storm outlook over the coming week, we do have several big flare players on the Earth-facing disk this week, including region 3004 and region 3006, and this does mean that we have big risks for radio blackouts. In fact, NOAA's giving us about a 60% chance of big M flares and even a 25% chance of X-class flares over the next few days, and things may settle down just a little bit as the week progresses. But remember, we do have that new region that's going to rotate into Earth view here over the next couple days, and it could be a big flare player too. So that means radio blackouts are still on the menu for Earth's day side, and this does include issues near dawn and dusk for you GPS users, so stay vigilant. Now we also have solar flux sitting well into the triple digits. This could actually boost into the 120s when that new region rotates into view. We're just going to have to stay and see how it pans out when that region rotates into view and to see how active it is. But amateur radio operators, this does mean that we should get some decent radio propagation on Earth's day side, and it will maintain like that easily through the rest of this week and possibly next week as well, as long as you can handle all the noise on the bands from all these big flare players. Now, as we take a look at the radiation storm possibility, right now we're sitting at the D1 normal level, but we do have an elevated risk for radiation storms, and this is due to those big flare players rotating to the sun's west limb. We have about a 10% chance of a radiation storm over the next few days, and that risk will easily remain like that and possibly grow over the next week or so. We're just going to have to stay vigilant. So if you are an airline traveler, or you are a GPS user at high latitudes, or an amateur radio operator, stay vigilant because we could get a radiation storm at any time. So the space weather this week continues to be a bit on the exciting side. We do have two big flare players in Earth view, and they continue to be firing off some big solar flares, and that could mean more solar storms could be on the way. Right now, we do have a stealthy Earth-directed solar storm that could give us some aurora at high latitudes. So aurora photographers, definitely keep yourself on your toes. You could get some decent aurora shows at high latitudes. Mid-latitude aurora photographers, you're likely going to have to sit this one out though, but that's not so bad because we do have yet another big solar storm producer that's going to be rotating into Earth view, and that could give us some more solar storm chances here over this next week. So keep your fingers crossed. Now, amateur radio operators and emergency responders, well, I'm sure you're loving that solar flux being boosted, but you're not really loving all the radio blackouts. And well, sad to say that those radio blackouts may still be continuing over this next week with this new region that's going to be rotating into view. So be sure to stay vigilant and kind of just, hang in there because things will get better maybe over the next 2 weeks or so. Now, also you GPS users, definitely stay vigilant near dawn and near dusk, and possibly even on the night side, because we're going to have that weak solar storm, but if it brings aurora, that could be enough to cause some GPS reception issues for you. So as long as you stay away from those regions, your GPS should be pretty good. I'm Tamitha Skov, the Space Weather Woman. Thank you for watching.
One, two, three. Hello. Okay, we're back. We're back. Four. Yep. All right. That was a USB switch on the mixer. I had to press to get that to work. We're back. We've got to make this easier. Anyway, thank you, Tamitha Skov, for your detailed space weather report. I don't know whether she hangs around and waits for me to broadcast it over here in the southern hemisphere, but that report went out a few days ago, so it's more or less just a report to let folks know where we are in the scheme of things. 1, 2, 3. Just making the mic gain up a little bit more. Right, let's finish with the space weather report like I normally do, and we'll bring up the latest image of the sun. And that is the disk of the sun. So what those watching in HD on YouTube can see the detail in that image. But as we speak, there are 1, 2, 3, 4, 5 noted sunspots on the disk of the sun as we speak. The solar wind is currently at 337.7 kilometers a second, at a density of 5.77 protons per cubic centimetre. The current sunspot number is 112. And the radio sun, measured at a wavelength of 10.7 centimetres, is at 133 solar flux units. So that's certainly up. Slight chance of storms today. One of the many CMEs that appeared set to miss Earth this week might hit after all. NOAA analysts say that a glancing blow is possible today, potentially turning Friday the 13th. Oh, is it Friday the 13th? It is too. Isn't that interesting? I didn't know that. Anyway, potentially turning Friday the 13th into a lucky day for high altitude auroral watchers. Minor G1 class flare geomagnetic storms are possible if the CME grazes Earth's magnetic field. Now I've got an interesting image here, courtesy of spaceweather.com. Let me bring that up. There it is. Slightly blurry image, but that'll do. What you're seeing there is the first sun quake for solar cycle 25. 26 years ago, researchers discovered seismic activity on the sun, A team led by Dr. Alexander Kohoskovich, then at Stanford University, found circular waves rippling from the core of some solar flares, like this image. They named the tremors sunquakes, much like earthquakes, except incredibly more powerful. A typical sunquake contains 40,000 times the energy released in the Great San Francisco earthquake of 1906. These solar seismic waves appear to be compression waves like the P waves generated by an earthquake. They travel through the sun's interior and probably recombine on the opposite side of the sun to create a faint duplicate of the original ripple pattern. Kozotkovich and colleagues have since observed hundreds of sunquakes. Not all flares produce them, which is a mystery. Moreover, the ripples behave strangely. A typical wave starts off at an initial speed of 20,000 miles per hour, then accelerates to a maximum of 250,000 miles per hour before disappearing. No one knows exactly why. We have just detected the first starquake of solar cycle 25, announces Kohoskovich, who is now a professor at the New Jersey Institute of Technology. It rippled away from the X 1.5 class solar flare on May 10. The movie below, centered on the blast, shows the concentric rings emerging from a turbulent surface sun. Oh, you can't really see. Oh, you can see it. Yeah, I didn't download this image. It's a black and white image. It's a bit vague, but you can actually see the ripples out along the surface. I would suggest you go to spaceweather.com to see that. Okay, so the last thing is potentially hazardous asteroids, PHAs. They are space rocks that are larger than approximately 100 meters that can come closer to Earth than 0.05 AU. None of the known potentially hazardous asteroids is on a collision course with our planet at the moment. However, astronomers are finding new ones all the time. As of the 13th of May, Friday the 13th, there were 2,279 potentially hazardous asteroids, and we still have about an hour before midnight, so there's still a possibility that Friday the 13th might be associated with a colossal impact from a rogue asteroid. We can only hope. Alright. I'm only joking, of course. Of course, they can collide next Saturday if it wishes. Alright, this is VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria, with a regular Friday night broadcast coming to you from the studios of VK3 CSJ, Narre Warren South. I'll be saying that all again in just a few moments. Meanwhile, we shall close the transmission on 160 metres AM. Would appreciate reports. So I've got a good report from Don up there. He's receiving the transmission on 160 with good signal strength and good quality. He says the signal on 160 is 30 dB over. He says the AM sounds fantastic through his hi-fi speakers. And I know that when I monitor the audio through my monitoring port on the Pro 3, it does. It really does sound perfect. When I was listening to Tamitha through it before, and it sounded quite fine. So, and that's exactly the way I want it. So I might end up broadcasting AM on 80 meters. It might make things a lot easier here too, on another point of view. Not quite yet though. Anyway, this is VK3 EKH ASV Radio. We shall conclude the 160 meter medium wave service, not surface, but service. So all reports can be directed to vk3ekh@gmail.com. We thank you for listening to 160. Anybody who has been listening to the 160 transmission, and g'day to Steve, Mr. VK3SL, who is probably listening in the background as well, who will be coming up on 1865 no doubt in a short while on AM2. with a test transmission. This is VK3EKH, concluding transmissions on 1865. There will be a quick callback on 3541 on 80 metres. And what else? No, I think I'll leave it. If I carry on, I'll just be prolonging the agony. So on behalf of the Astronomical Society of Victoria, and we also like to, the ASV has now a new president, Mark Ascario. He became the new president. I should know the number of presidents. There's been quite a few presidents over these years since 1922. I wouldn't even hazard a guess at the number that he's sitting on without counting it. Welcome Mark to the position of the president, and David Rolfe, VK3JL, is the vice president now of the ASV Society. So well done to Mark and to David Rolfe, VK3JL, for their new positions within the society. I wish you all the best, and I know that you want to move the society along into the future. So well done, chaps, and to the new committee members as well. All right. Okay, this is VK3EKH concluding on 1865. Thank you for listening. All right. Now, standby stations on 80 metres. Got my pen. All right, this is VK3EKH. Who was listening to tonight's session? I forget. What do I say? What do I normally say? This is VK3EKH listening on 3541 for any stations wishing to call in. That's what I normally say. Go ahead. Okay, VK3JR, VK3HDX. There was a weaker station. It sounded like KKT. I'm not too sure. VK3 Delta X-ray. So the station after Don, VK3HDX. I've got VK3JR, HDX, and there was another station that called in before VK3DX. Who was that? Go ahead. So Kilo Hotel, I think, VK3KH something. Go ahead. Oh, okay. Yep. Sorry, Bill. We got you. Yeah, not super strong, but we got you. Each time I have a trouble with a call sign, I write over it a million times with my pen, and it becomes unreadable. I mean, for those watching TV, this is what I end up doing. See how I just go over it with a pen. Sarah, can you read that? So it's just, I'm hopeless. I really am. Take it away, Frank. VK3JR, VK3EKH.
VK3JR. Good evening, Quake. Good evening, everyone on frequency. You've got a new clip, great broadcast. Very interesting, of course, about the photos of the accretion sticks around the center of body there. There's that very, very big black hole. Most interesting indeed. I was interested in you're telling us about perhaps I'll leave that. The number of exoplanets is the same as it was last week, 4,711. And otherwise, I don't have anything to report. Thank you for doing it, Steve. Steve. Thanks for doing it, Steve. You're getting through very well on 160 on the coffee break, enjoying that as well. VK3JR.
Good on you, Frank. VK3JR, VK3EKH. Oh, I didn't know you listened to the coffee break as well. Well, there you go. The coffee break's a bit of fun. You want about the only thing about the coffee break is that you only get a chance to talk twice, and that's it. So if you've got any questions, you say it in the first over, and then you wait for the next round for any possible responses or whatever, and then the second time you get a chance to talk, you say thanks, and that's it. The coffee break net could easily go for another half hour, I reckon, but the old timers there on the coffee break net, they like to finish right on midday, and then they go off for lunch or have a nap in their chair. Anyway, that's the coffee break net. The coffee break net's an AM net on 160. It starts at it's on 1825 kilohertz, and it's been running since the 60s, and it's what got me into ham radio initially, and I'm quite happy and chuffed to be one of the caller-inners on the coffee break net at 11 o'clock during the day. Of course, it's only weekdays, and there is a session on a Sunday morning, but it's not as big as what happens on the week. Enough of that. Thanks, Frank. And yes, the image is quite spectacular. And again, once again, you remind me about the exoplanet business. I must really do something about that. So I've got an updated figure in front of me here that I can rely on. Across to you there, Don, VK3HDX with the hi-fi speakers connected. I can just imagine in that subdued room you're in with the blue glow from emanating from all those screens. VK3HDX, VK3EKH.
Great broadcast tonight. Very interesting. Love the photo as well. Love the photo of Mars too. That was very Doctor Who-ish, I think. Great broadcast. Enjoyed it. Love listening in AM. Would love you to do it on 80 metres. Don't know what others think, but it really does sound great. So the only thing we're going to do
Next week
is fix the delay up between the YouTube and the live radio broadcast. No, it's very good and very entertaining. Thanks for the effort you put in, and we'll look forward to next week. VK3EKH and the group VK3HDX.
Thanks, Don. VK3HDX, VK3EKH. All right, well, I might run the broadcast on AM next week. I know I've done it once before. I just decided to run AM on 80 meters. But for those who don't have AM on the AM mode on their radios, you can still very easily zero beat my carrier, and you're hearing me perfectly well. But I'll set the system up next week to run AM on 80. So for those that are getting a reasonable signal from me on 80 meters, you'll hear a reasonably good AM signal too, I think. So that'll be cool. I'll do that. Be interesting to see the reports I get next week. All right. To Bill, VK3KHT. You're kind of 4x9, not super strong, Bill, but we are hearing you. VK3KHT, who's no doubt watching the TV as well. VK3EKH. Yeah, that's better.
Why it's about 5 seconds ahead. The clock on
Thanks, Bill. VK3KHT, VK3EKH. Yeah, that was a much better copy. You're you're hovering between 10, 20 over 9, somewhere between 10, 20. So you came up 5 and 9, or 4 by 9 thereabouts. It was in my noise, but changing the antennas definitely lifted your signal. So that's doing a whole lot better for you. That's for sure. Look. The only thing, as you would be aware, the only thing to be aware of is the clock on the radio here on TV is displayed a little bit later than real time because of the digital delay in the repeater. So I would say that the time displayed on the TV up there, and you certainly can't rely on YouTube because there is, as Don pointed out, there's quite a massive delay on the YouTube channel, and so don't rely on anything you see on YouTube, and that's right across the whole board too. I might mention. Oh, that's not true. There's a lot of good stuff on YouTube. I mean, a lot of really good, interesting stuff, educational. Yeah. So I would say I'm just looking at my my clock, the clock on the computer. It's currently 11:20. I'm just sort of waiting for it to go over to 21, 11, it's still 20 at the moment, 21 now.